Our mining business is a global business. We've got a lot of great global experience, and I think a lot of cool things that we can talk about today in terms of what we're seeing across the industry.
Hello, everyone. Welcome to Mining Now. I'm your host, Jerrod Downey, and we are filming another episode from Salt Lake City for SME MINEXCHANGE. It's been a great event so far, and we have a great lineup coming up on the show. First-time company feature and all first-time guests. Please don't say you've been on the show before, because then I'll feel bad. I think everybody's their first time on the show, time, and we are featuring WSP today. Very excited to have you on. We've got Scot Foster, Senior VP of Global Mining, of the Global Mining Program. Randy Huffsmith, Senior VP and U.S. Mining Sector Leader. And Sofia Berger, Business Line Executive, Earth and Environment. Do I have all that right?
Got it.
I see that you all have LinkedIn as well, so people will connect directly with you if they want to chat more, or if I miss questions. I always think that. People probably watch this going, can you just ask this? Who wants to kick off just giving the WSP macro, just who you are?
Let me take that
all
one.
Right.
So first of all, thank you so much for having us on the podcast. We're super excited about today's conversation. I think it's going to be really interesting. But just to give everyone a little bit of a briefing on what WSP is, we are an engineering services company, and we cover a wide variety of disciplines, everything around your infrastructure development needs. So obviously earth and environment, which we'll talk a bit about more right now, but also transportation and infrastructure, advisory and planning, power and energy, property and buildings, really everything you need in the built environment to continue to advance communities. And particularly today, we're here talking about our mining business, which is part of our earth and environment business. Our mining business is a global business. We've got a lot of great global experience, and I think a lot of cool things that we can talk about today in terms of what we're seeing across the industry.
Just for my own curiosity, do these different sectors, do they overlap at all, like underground tunneling for in municipalities, things like that?
So that's a great example, because that's one that actually happens. So we have a very strong legacy tunneling group for subways all across the U.S., including the original subway in New York City. And they work all the time with the geotechnical teams that we have in earth and environment that are working on, deep caverns or, large mining projects or all kinds of geotechnical needs.
Let's walk through it. Scott, let's start with you. What is everybody's role here?
Yeah, I work with the U.S. mining business. I had a global role for a number of years, starting with Golder, now with WSP. I work with Randy and Tom and the executive team here in the U.S., focusing largely on the commercial side of our business, working directly with clients, some of the largest clients like Rio Tinto, BHP, Freeport, and so forth. So really bringing opportunities into the company, nurturing those opportunities, developing them, creating them, building the teams around them. And importantly, as Sofia described, all of the various things that we do, many of those client engagements require more than just mining. Infrastructure is a big part of what a new mine requires, right? So they need rail, they need water, they need power, they need all of these other things that WSP can bring to the table, and we're fairly unique in that way.
How many? I'm just curious. How many people would get, if like a major mine? I'm talking like a large production facility. How many people from your team would be involved in that sort of, like you just walk through some of the infrastructure? I mean,
well,
must be a huge amount of people.
I mean, I think it could easily be hundreds over the course of it, right?
Wow.
I mean, so we do the whole service development. So at the beginning, you have your planning services. That's a relatively small but highly multidisciplinary group as you're helping the client really decide how they're going to push forward that mine. Then once you've got that, then the environmental clearances and the permitting and all of that, you get into the design, and then you get into the construction management, and then even the operation and maintenance, or the maintenance and reliability, depending on the owner. And we help across that whole spectrum. And so it would be different professionals, but easily hundreds over the life of it.
Amazing. What is your role?
So I lead the earth and environment business here in the U.S. We have 4,600 employees in the earth and
Is that
environment
all?
business here in the U.S.
You know, a company's big when they just round the number. I still say we have a team of 11. Brandy, what's your data?
So I'm the U.S. mining sector leader, and I spend a lot of time connecting our clients to our resources. So a very significant number of resources, as we've talked about, across the U.S. And when you have 5,000 people and globally 70,000, there's a lot of different disciplines. And my objective, or our objective, Scott and I both, put the best team on the field, right? Bring the best resources to bear for the client. Make sure that they're getting the services that they need.
So you kind of have to custom build it each time in a way?
Absolutely.
Interesting.
All of these mining projects are different. The metallurgy is different. The mining methods are different, and we have lots of different technical professionals that can support those processes as they move forward.
Scott, I wanted to get into the rare earth minerals. That's the big topic, the demand. Obviously, the U.S. there's a shift in the U.S. right now to be more self-sustaining, bring it home, that kind of approach. Can you just let's just talk about that,
Sure.
Kind of, and we'll dig into it, but just as an overview.
Sure. Yeah. A few points worth making, maybe as kind of a broad overview. As you point out, we are heavily dependent on imports. Something like 90% of everything that we use and put into end products is not generated in the United States. That supply chain uncertainty, set geopolitics aside, that supply chain uncertainty is just not tenable over the long term, not sustainable, and it's just not good business. It's not reliable. And if you look at the way we are embarking on a real greening of our energy, renewables and so forth, and then EV cars, if you look at the average wind turbine out there, that consumes about 300 kilograms of rare earth materials per wind turbine. If you look at the amount that we use on an annual basis across all of the various sectors here in the United States, it's massive, and none of it is currently, well, got to be careful, a little bit is coming from the United States. We'll get into that in a little bit here. But really, I think it's the marriage of lack of supply, poor supply chain stability and longevity, I guess, and really a massive increase in the future need for these particular materials. They're so unique. Rare earths, by their very nature, are rare and unusual, and we'll talk a little bit more about why that is the case. But it puts us in, as a nation, in a fairly precarious position. So,
what does that supply chain look like today when we're talking about it? Right as we're speaking,
Yeah.
When you're talking about 90%, is that how reliable is that supply chain? I know it's different by different sectors.
Right, it's going to differ, but look, the vast majority of it comes from China. There's no way around that. China is blessed with a massive resource of these particular elements. We are blessed with some, but not a lot. We have found a way to develop some of that. We have one active mine on the border of California and Nevada. It's called Mountain Pass Mine. MP Materials operates that. That's our one and only mine for these particular materials in the United States. That's it.
What kind of materials are we talking about?
Well, we're talking about the rare earths, lanthanides. It's a whole series from atomic weight 52 to atomic weight 70. It's a whole series of about 12 elements that are very unique in their chemistry and physics, and that's what makes them particularly useful in building the kinds of magnets that we need in electric motors, for instance, or in consumer electronics. These things don't work without these particular materials.
Wow. And so there's one mine.
We have one mine.
Wow. And then so that import, you said 90% is being imported. Is that 90% not all from China, though?
The vast majority is.
It is. Wow.
But there are other, Australia, we're importing some from Australia. Southeast Asia, we're drawing small amounts from Southeast Asia. Canada has a tiny amount. I don't think we're actually importing any from Canada. South America, Brazil's producing a little bit, but there's a real paradox with Brazil. We'll get into that in a bit, but the paradox is they have a massive resource, but they're only able to get out a small quantity into the global market. So as we look around the world, we're really trying to stabilize and our supply chain, really trying to get the materials that we need from friendly, reliable sources. And, I mentioned geopolitics earlier. It's a reality. we're facing uncertainty, and that's what I believe is untenable and unsustainable.
So are the elements in the are they in the ground in the U.S. though? Is it?
Yes.
They are there.
Yeah, there's a fairly abundant supply, maybe not like China has, but we've put ourselves into a position in the U.S. And post World War II, we were the industrial leader, right, and the mining leader in the world, and really for two reasons. One, because we needed to be to support the war effort, and two, because unfortunately the other superpowers were bombed into ruins, right? And so the industrial world was here in the U.S., and it built that way through the 70s. And then as the 70s rolled in, we started to realize that there were environmental consequences to these industries. Our labor laws were challenging, right? And we began to make those changes that we needed. We started paying miners a living wage. We started putting in environmental controls. We did all those things, and what we found was the other countries were behind us in all of those efforts, and those efforts cost us money, and it makes us less competitive economically. And so the result was when rare earths rolled around in the mid-'80s, we were in the middle of that kind of storm, that those issues were at the forefront. And so there weren't very many mines developed, and other countries came in and they made that development. And Scott mentioned and talked about the risks of the supply chain, and if you look at the rare earth market, it's actually a very small market compared to copper and iron ore, which is enormous, right? Billions of tons. Rare earth's a small market. And so the result is that a few dominant suppliers can control that market.
Oh, I see.
And so, things like flooding the supply, as an example, or they have a geopolitical hammer where they can tax imports, or they can make a policy around their currency that changes prices and makes it easier or harder to buy these materials. So our rare earth processors are faced with those realities, right? And so what we need to do, and what's been happening today, is we're focused on things that make us more competitive, right? And at WSP, one of those things is technology, right? And if you look at the technologies that are out there now, they're cost saving, they're environmentally friendly, they're helping our miners succeed with that challenging environment. Things like autonomous hauling, battery electric vehicles, solar fields. All these things have very good environmental consequences, but they keep the prices down for our mining companies.
But they also increase the amount on rare earth.
Yeah.
Right? That's the offset.
That's the advantage. And, the current pathway is what Scott and I have been working on, and our folks at WSP, is the Fast 41 program, which is a U.S. government program designed to effectively streamline the process for getting a permit, getting a mine in production, where it used to take 7, 8, 10 years, which is a very costly timeline. The objective is to reduce it down to 1 or 2 years so that these folks can get into production quickly.
Didn't the U.S. government just designate, like a year ago or so, didn't they just designate a whole new list of, there's a term for it, you know it.
Potential candidates for Fast 41 permitting, yeah.
Yes.
But they also labeled a whole bunch of rare earth
strategic metals.
Like high demand, like in emergency situations.
Critical minerals.
There we go. Critical minerals. There we go. Sorry.
Yes, the
rare earths are all within that critical.
And some of they added some new ones that weren't in there before. Yeah, because the world has changed now. There's demands on certain things that weren't. In the 40s it wasn't a demand. Now it's used. Sofia, again, sort of zooming into that bird's eye, or zooming out into that bird's eye view. I feel like this is here to stay. But are there elements that are trend, and are there elements that are in 30 years the demand's still going to be there? Do you sort of have that outlook?
Yeah, so I mean, we've been thinking about the ongoing demand a lot as we've seen this move, and we definitely think this is a structural increase in demand. This is not cyclical. If you look at a lot of the analysis, they're saying here in the U.S., the demand is going to grow 9 to 10% per year in the foreseeable future, so way more than our GDP is growing. But also, if you look at how these elements are being used, as Randy was saying, this is not a bulk commodity. This is an enabling material. And the way that they're enabling these technologies, there's no good substitute now. So there's not any other option. And if you look at...
crazy.
Yeah. I mean, lots of people are trying, but nobody's cracked that nut yet.
Right.
If you look at the main drivers of the demand, I think these are trends that are here to stay. So number one driver of the demand in the U.S., electric vehicles. So, I mean, all the electric vehicles that we see happening around us, I mean, that trend is continuing,
Which make
right?
up, what is it? They make up like 2% of all the road vehicles.
Only 2% right now. It can only go up.
Nothing.
Exactly.
It's nothing.
In Europe, I think they're barely over 5%. I mean, there's a long way to go here until we have saturation in the EV market, right?
Yeah.
So that is the number one driver of the growth. Second behind it is wind turbines and grid electrification, or grid infrastructure, as Scott was saying. Definitely a trend to stay as we see much more demand on our grid infrastructure with data centers and electric vehicles and all these things like that, right?
Especially as older infrastructure needs
to be rehabilitated.
Right, yeah.
Exactly.
Wow.
And then the third important driver is the defense industry, which volume-wise is actually a much smaller draw. They don't need as much, but it is security sensitive, which is why it was designated as a critical material by the Department of Defense. And so, I mean, those three drivers alone, I think, really indicate that they're here to stay, because again, that's without even talking about consumer electronics. Everything that's getting smaller, miniaturized, is using rare earth elements. So there's really a lot of uses here. And so, part of what we see is more people need to be aware of this, because, when we talk to departments of transportation of how they need to build out for electric vehicles, they're just not even thinking about the dependencies here and what they need, what really comes from the earth to be able to make all these things happen, like the rare earth minerals.
Well, and then powering it, right? If you took the grid and doubled the demand on the grid, I mean, it's a quick Google search, you'd be impossible. It's not going to happen.
It really highlights the importance of these mining projects.
And so that's the downstream piece of that. So here's this downstream piece that's very robust, right? And I made a list: pacemakers, hearing aids, dental implants, cell phones, computers, speakers, wind turbines, missile guidance systems, jet airplanes, AI technology, radar, and many, many other uses, right? So that's our downstream. The upstream is a mine, right? Open pit, underground. In some cases, we're processing waste, old mine waste. In some cases, we're getting rare earths out of water. That's where it starts. The next piece of the supply chain is the concentrating. So you have to take those rare earths that are in very tiny concentrations and you concentrate them into a concentrated product. And then that product goes to a refinery. And the refinery turns that product, be it neodymium or another rare earth or a group of rare earths, into a product that can go to a magnet factory. And then the magnet factory then puts them in your watch or in your cell phone, creates the magnet that's needed for the product. And so all that front-end supply chain we're in trouble with in the U.S., right? We're barely building the magnets. We're hardly processing the ore, and we're barely mining the ore. And so it is a big push right now to get us into a position where we're not held up in this geopolitical situation.
It kind of reminds me of all the superhero movies where I don't really watch them, but the ones where they're looking for this element that is running the whole world, and you think, oh, that's ridiculous. No, it's exactly like that.
Kryptonite?
I can't even name the movie, so thank you. I stopped watching after Spider-Man. I just couldn't do it anymore. Okay, so you're mentioning about the downstream. Does that, whoever wants to take this, do they ever work the other way in helping sort of the upstream side develop?
Yeah, great question. Look, a number of these companies, they're not only producing the raw materials, but they're aiming toward a full cycle or full value chain, if you will, to actually get the United States in a position where we ultimately want to be, right? So we know that MP Materials out there at Mountain Pass is currently building a processing facility to make magnets in Texas. I think 2 or 3 of the others that are currently producing or getting ready to produce over the next few years, they also have plans to develop processing plants and magnet facilities, oddly enough, also in Texas and Oklahoma. So I think the important takeaway here is that we're moving the needle a bit towards that goal of independence. Again, I don't think we'll get there, but the more we can do on domestic soil with regard to that entire value chain, certainly the better.
Any specific reason you see it being Texas being kind of this hub?
I'm scratching my head over that one. It seems to be convenient. If you look at USARE, their biggest piece of property is in Texas. It's Round Top over near El Paso. But I don't think that had anything to do with it. I think they had other reasons to be looking at the Oklahoma area. MP Materials, why they chose Texas? Don't know. When you think about Texas, think about the long history of resource extraction and processing. Right?
Yeah.
Right. Okay, they're about as friendly as it gets to the resource industry,
and probably won't change anytime soon.
And good access to ports.
Good access, really good access to ports. Good infrastructure. I mean, Texas is an ideal place in so many ways. But there's going to be the need to be shipping that from Wyoming, from Nebraska, from Idaho. California, wherever it might be. If Texas becomes our central hub of processing these materials, I think we're onto something.
Yep.
Interesting.
Absolutely. And the nice thing about rare earths is it's not like shipping huge volumes of copper concentrate, right? It's a much smaller volume, so it can be done effectively from state to state as compared to giant iron ore projects and that sort of thing.
Where something has to be close enough to even make it remotely tenable. Yeah, I see. Scott, I wanted to ask you about projects that are getting going. Is there, we've talked about demand, we made that really clear. Now, what's the next step? Are there projects that are getting off the ground? Are there ones that look like they're going to get expedited?
Absolutely. I said earlier, China is truly blessed with massive resources. We've got some pretty good resources here in this country. I'm going to nerd out for just a moment if I can, speak to the geologists out there. I am one.
I think that's the whole audience.
Right?
You're not going to talk about ad nauseum, are you?
No. I'll leave that one out. You can work on that one.
I actually have timer notes on some of these.
Look, there are basically 3 different types of rare earth deposits. Okay, one is what they call a carbonatite, and I don't have to go into what that is, but the geologists will know what that is. The other one is ionic clays. And then there are a basket of other things. We've got here in this country rhyolites that are enriched in rare earths. We've got phosphates that are enriched in rare earths. We've got coal seams and clays and so forth. But the big ones are these carbonatites. Okay, Mountain Pass on the Nevada-California border. That's what they have there for a resource. We've also got Halleck Creek that American Rare Earths is developing in Wyoming. That's another carbonatite. RER, Rare Element Resources, has got one in Wyoming called Bear Creek, or Bear Lodge, excuse me. Another carbonatite. So there are a variety of these out there, and most of them are comparable in scale to Mountain Pass. In terms of what we like to think of as a total rare earth oxide equivalent. Okay, so Mountain Pass has got a reserve or a resource of about 2 million tons. Yes, about 2 million tons. China alone has anywhere from 40 million tons to 100 million tons. What you see in print is 40 million, but everyone thinks they're closer to 100. Everything that we put together on all of these projects, plus the existing mine here in the United States, I can't get us past about 15 million tons. So
China is what?
40
to 100.
40 somewhere to 100. Brazil, interestingly, I talked about the paradox with Brazil. Brazil's got about 20 million tons of rare earth oxide resource. I won't call it a reserve. It'll be a resource. So when you look at us relative to other parts of the world, and here's a funny thing. Normally you think of Australia and Canada as being rich in resources. Mm-hmm. They're not terribly rich in rare earths at all, Canada in particular. There are a couple of companies that are developing and producing rare earths in Australia, but small scale, in this 1 to 2 million ton kind of range in terms of resources. So yeah, there's at least a good half dozen, and they sort of span that. They're mostly carbonatites, but the others are ionic clays and sort of a variety of other odds and ends, but they are all tiny by comparison. So you have to be blessed with good geology. The geologists out there will appreciate that. And then you've got to have the downstream in order to actually do something about it. And that's where we're suffering. We've got enough resource to close that gap that we have right now. We've got a gap between supply and demand domestically.
Sorry, Scott, I just wanted to kind of understand. So you said, though, if you put it all together, it would total up how many?
And
2
people
million?
can dispute this, but I'm thinking 15 to maybe as high as 20 million tons.
Okay.
Now, here's
and the demand is what, though?
The demand is huge. It's going to be much greater than what we are currently able to supply. So I'm going to go out on a limb. And, I may get a little pushback on this, but I'm going to suggest that we are unlikely to be entirely independent as a nation with our own resources. We are going to have to nurture and protect those external resources forever if we want to keep on the path that we're on today. We're going to make up some of that gap, but I don't think we'll ever completely erase the need for partners out there who are willing to send us their resources.
Just because of the amount of production that you need to green light for it to it would be a massive.
Absolutely.
If you start all products tomorrow, it would be the biggest project ever undertaken.
Yeah. I mean, these things and these projects take years, as Randy was pointing out. Even with Fast 41 helping to accelerate the whole permitting process, the design and the construction is years. I mean, these things. If we started today on all 4, 5, 6 of these things that we, are involved with, or we know about, you're at least 7 or 8 years out before they're, all producing at a level that's going to really start to close the gap. So, we've got a challenge on our hands.
No, and that's where I think, the more likely scenario is that we diversify our sources, right? I mean, like any good financial advisor would tell you, right? You want to have a diversified portfolio so you're not too over-dependent on one thing,
and with the market hiccups, there is some shift around.
Exactly,
right?
exactly. And so, I think that's what a lot of scenarios are showing. If the U.S. can get to a scenario where 25 to 30% of its needs are taken care of domestically, that just gives it a lot more balance.
Well, I think a good example is with the chips.
Yeah.
Right? Mm-hmm. My family drives all these dually trucks and all that, they're horse people, so they've got all these trucks going everywhere. You couldn't get a truck. I think it was Dodges, they were all sitting in a lot without chips. Yeah. You couldn't get them. Mm-hmm. They just sat there. They didn't have the chip. And I mean, just that, it's that hiccup in the market that you cannot make a shift. If it goes wrong, it just shuts down. Mm-hmm. It just stops.
I like to liken the issue to toilet paper and COVID, right? Mm-hmm. it's the same thing, right? The supply drops, people go crazy, they fill their garages full of toilet paper, right? And if you're Lockheed or you're a manufacturer and you need rare earth minerals, that instability is a big challenge for you, right? And if we look at even the U.S., right, in the 1900s, we had big trusts. We had big monopolies. And if you think about Standard Oil and you think about the railroads, right, we as a country decided that we cannot let a select few dictate the economic consequences in an entire country.
But now that has happened outside the border, that a few are dictating. Yeah.
Yep. And so again, we've got to look at what tools we have to keep that from causing consequences in the U.S. right, and things like ethical sourcing, right? Do we really want to spend a few less dollars on a product, knowing that slave labor or very poor environmental conditions result from us saving a few dollars on rare earths? I don't think we do, right? the other piece is technology, and we've talked a little bit about that, but technology is going to help us be more competitive. And then the last piece is, to support the industry, and that may take, in some cases, the government programs like Fast 41 or even subsidies. We're starting to see government subsidies, those sorts of things, so that we can kickstart these and not be 100% or 90% reliant on a single source.
And government investments, right? As
yes.
Many of the
I was going to
mines
ask about that. Yes.
that Scott just mentioned have explicit investments by DOE or DARPA or U.S. Exim Bank, Department of Defense. Very explicit
Which
ways.
will be needed.
Absolutely, that
It
the
just
U.S.
has to
is
happen.
helping push those forward. And also you see important agreements from major OEMs, so Apple or Lockheed Martin, saying, hey, well, if you develop this, I'll guarantee that I can take off some of that supply.
Well, Tesla was looking at getting into the mining.
Exactly.
They may still be, but yeah.
And you need that, right? I mean, this is a major investment that you're putting in. You need to know that there's going to be demand on the other side.
Right.
And the U.S. government is not only investing in domestic resources, but they're investing in Greenland, Tanbreeze. They're investing in Iluka down in Australia. And they've got their feelers out for opportunities
Building
to
a supply chain.
build that supply chain, which is exactly what what Sofia was talking about with a balanced portfolio.
Right.
And my point about never being able to make that up on our own.
Right.
We've really got to just be smart about how we take this forward as a nation.
I got to ask, Randy. I'll start with you, and then everybody jump in. The risk. This is something I've talked about on the show. If you want, I've used copper as an example. If all of a sudden the demand triples and everything starts getting green lit, now there's another risk, because if you go faster, quicker, less red tape, what are the risks to that, and how do you counter those risks? Like, I'm talking about environmental, safety, training people, bring people, that you got an aging out population in the mining sector, now you're trying to bring younger people in. They don't want to go to a mine way out.
Right.
So what are the risks? How do you counter them?
Well, you mentioned a bunch of them, right? So it is, I think, understanding and training our younger professionals, right? Getting them engaged early. And there's a lot of programs. SME, we're here now, right? A huge education foundation, right? And scholarships and programs that really help the mining industry, and with a direct focus on leaving a legacy for our younger generations to be able to carry forward, right? And lots of education, right? And a lot of things we can learn from younger generations as well, right? Technologies move quicker, and the younger generations are very good at these new technologies. So all of that's molding into something that I think is very exciting for our country and our business, to have that sort of resource.
What's funny, there was a lot of the new generation. They're starting to put their technology out of the way. They're starting to want it. Like, no, we want to go to this old time. They're buying people are buying old trucks again, and deleting social media accounts. It's a funny trend. It's interesting that now that 25 generation is starting to want some of these. They're looking back now, going, oh, those days actually do look nice. But anyway, that's a little side note.
And we do, in our business, we attract people that are hands-on, because that's what mining is, right?
Yeah, it still has that thing.
And so they get out in the field and they can see the geology, like Scott spent many years doing that, right? They can watch a building go up. They can help design that building. They can work on the processing. Yeah. All those pieces, right, are very hands-on, and so it's a very good industry for that.
I do think mining actually does need to be a little bit careful with trying to just promote themselves. It's like, hey, we're like a technology. It's like, no, people are okay with adventure. People are okay with things being hard if they feel that it's rewarding and that young people do want a challenge. If you ever watch a young sports team and the coach doesn't push them hard, kids just stop showing up. Push them hard, and everybody wants to go. Now, there is this balance that needs to happen.
Well, and I think that field aspect is one of the things that's really beautiful about the engineering industry, if I can say, because you really see the fruits of your labor, right? I mean, you put a lot of work in, but then you see whatever it is, the mine, the road, the building grow in front of you, and you see how it impacts communities and has real results. And so, that's a really great part of what we do.
No, that's like the construction industry. You see people, you drive by, and I help build that, and it's people are proud of it. Scott, I wanted to ask you, though, these projects, though, what does make them hard to execute, though, to actually get them going?
Right. Great question. And lots of layers of that onion to sort of peel back. Financing is probably right at the very top. I mean, these things are not cheap. They're not cheap. They're extraordinarily complex. Oftentimes, they're what we refer to as a greenfield. They're not in an industrial area. They're out in the middle of pretty much nowhere.
Right.
So you think about the infrastructure that it takes to build a mine from scratch, and just the sheer volume of moving all of that material and trying to extract the things that you're interested in. So the financing, permitting is a bit of a challenge. That can be anywhere from 5 years to 10 years. I mean, we see examples here in the United States where mines are just kind of put on the back shelf for the next 10 years because they're just not going to get permitted. Now, Fast 41 is doing a great job. The U.S. government's made some real inroads in the recent past trying to accelerate that whole process and remove a lot of the redundancy, remove a lot of the just sitting on permits. So it's putting all of these various government agencies into a structure where they are accountable. If you agree that you're going to do a 60-day review, you're going to do a 60-day review, not 2 years. You got to have it done. And the Fast 41 team, the permitting council, is empowered to get on top of the Forest Service or the BLM or whatever it might be and insist on, hey, look, 60 days is 60 days. You don't have 2 years to do this. So Fast 41 is a great example of how that whole permitting issue is being addressed. I talked about lack of infrastructure. Big issue. I mean, we do all sorts of infrastructure across everything we do. You got to start from basically a barren piece of ground. You might be in the Alaska wilderness. You might be in the Southwest desert wilderness. You're generally not outside of Salt Lake City building something up on South Jordan.
And if you are, good luck getting it built.
Good luck getting it built. Yeah, they started that one 150 years ago.
Yeah.
They were lucky that they could. Look, with rare earths, every project, every deposit is unique, and that brings complexity and challenge. Gold is gold is gold, right? I mean, there are a few ways to extract gold, but you're generally going to use cyanide, almost always. Copper, there's a couple of ways to pull copper out of the rock, and whether it's oxide or sulfide or whatever, but fairly straightforward. When you get to rare earths, you've got 12 different elements, and every one of those has a unique chemistry and a unique physics and very unique extraction process. So each deposit has a different makeup. It's a different portfolio of elements. So you don't know until you get into that what you're really dealing with. Now, not every one of those is economically viable as an extraction product. So, for instance, Round Top has this suite of all sorts of rare earths, but it's only a few of them that are actually of interest for them to extract. And I'm sure I could go to Ramaco and Bear Lodge and Niocorp. I mean, Niocorp building this one in Nebraska, Elk Creek, they're really interested in the niobium. Mm-hmm. That's what's going to make them their money. So it's very unique, and it's not prescriptive, and you can't just cut it out of a cardboard box. It is challenging like probably no other hydromet operation on the planet. I'd say rare earths are probably at the very top in terms of the complexity. Yeah.
And I would add co-products to that. So
Right.
a lot of these mines look at there's other minerals, right? And
Right.
so they can extract rare earths, but they can make money in other ways, whether it's, copper or it's some other product, right? Some other element. So these mining companies look very holistically at their ore bodies and say, okay, what can we pull out that's going to be economic for us and make us as diverse as we possibly can be?
Yeah. I just to wrap up the interview, to kind of bring it home, and this, just a shameless plug, Sofia. How does WSP move the needle? What is your it's kind of a two-part question.
Mm-hmm.
What is your responsibility to the industry,
Mm-hmm.
and where are the opportunities as a company?
Yeah. Well, so So first of all, the responsibility to the industry is that, as you've already heard, we're very passionate about the role that mining has to play in continuing to advance our communities. And so we're excited that there's now all of this development around these rare earth element mines, because it's in different parts of the U.S. that didn't already have mining industries in some cases. And so there's a lot of needs in all those different places for them to know what it takes to develop a mine. And that's really where I think the multidisciplinary nature of WSP can help a lot. I mean, we've referenced Fast 41 a couple of times today, right? That's not a new program. And by the way, you don't skip any environmental stops. You just do it faster, just like Scott said.
There's
but
a demand to do it faster.
Yeah.
Yeah.
There's a pressure to, exactly. Right. But that program historically has been used mostly for transportation projects. And so we have a lot of people that have the experience on how to do it for transportation projects.
That is
now
a good plug.
We can mine. we can marry with people that understand
Right.
mining to really, and we already have helped clients in the mining space understand how to leverage the program, right? The infrastructure side that Scott has mentioned a couple of times, we feel like it would be a shame if you made all the decisions on where to put your facilities purely based on what made only sense for the extraction. Because if you didn't think about how then you're going to take that extracted material and whether it be by road or rail, get it to the port that you're going to get. I mean, if you didn't think about how the power was going to come in, where you were going to put facilities, and if you don't think interdisciplinary and holistically on these very complicated sites, you're really going to miss the picture and potentially make some decisions that then you're going to regret later on because they turned out to be more expensive. So, that is really where I feel like we can bring so much to bear, including the global best practices that we have, because we have been working with clients in Brazil, in Australia that do have other assets, and that we can really bring all of that to bear for clients here in the U.S.
Absolutely.
I promised a 30-minute interview. It's been about 40 now.
Well, I hope it was interesting.
I could just keep asking questions. There's so much to cover in this. I mean, this is not just an interesting topic. It's an important topic. Yeah. So I hope we can find an opportunity to do it again and maybe dig into some of these segments we kind of just spent a few minutes on, because some of it is actually, it kind of demands a little more time. But I do want to thank you for coming on. It was very nice.
Pleasure.
I've wanted to have WSP
pleasure.
on for a long time, so I'm very glad that we finally got to do it.
Thank you so much,
Thank
Jerrod.
you so much,
Thank
Jerrod.
you.
Jerrod.
And thank you, everybody, for watching. Like I said at the beginning of the show, all the guests, I'll put their LinkedIn in the description. Make sure to follow WSP, connect with them, and check out some of their other projects on their website and everything like that. If you have not followed Mining Now yet, please do. Thank you for watching, and we'll see you on the next episode of the show.